to another edition of Indexer Office Hours. Today is the 14th of February, a very special day, also known as Valentine's Day, and is also Indexer Office Hours 94. This is the town square for Graph ecosystem participants to come together to discuss the most important topics for indexers. If you are new to this call, welcome. We love participation. This is a conversation. So at certain parts of today's conversation, please do contribute via voice or text. And if you're having issues unmuting your mic or contributing via voice, please mention it in text and we can try and get that sorted for you. And with that, let's get into today's agenda.
So same slide as last time, just quickly, what is Firehose? It's a blockchain agnostic way of storing and retrieving data. Blockchain agnostic meaning doesn't matter if you're on Cosmos or Airweave or Ethereum, whatever, we store the data and then you can use the same set of APIs no matter the blockchain to retrieve your data. So the blockchain Firehose will follow cursors backwards and forwards. You can, if you drop your connection, you can tell it to resume where you left off. Makes it easy for application developers. And the big thing is all the blockchain data is stored in flat files, which allows for massive parallel processing when it comes to doing analysis of blockchain data, which is going to be really important for us. All right, so next. So just a reminder, we've got 3 different binaries that we have to work with here inside Firehose. We've got an instrumented blockchain binary or an execution layer client. We have a consensus layer client, and we have the Firehose binary itself. Next slide. So last time we saw this diagram, but I added some color to it for this time. So there's the black boxes, the execution client and the consensus layer, that's the same as before. For this exercise, we're going to merge all of the Firehose components into a single binary just to get us started, so make it a little easier. So rather than dealing with high availability and trying to do scaling, let's just do a simple example. So we'll put all this together. And we're not going to talk about the archive node or graph node in this presentation, but just a reminder, they do connect, and we did provide the configuration last time so you know how to hook up your Firehose to your graph infrastructure. So that still applies. We're just not going to talk about it today. So if we take this diagram and we collapse all those light blue boxes into one, we get to the next slide. Voila. So this is the deployment model that we're going to do. All the Firehose components all together, and then we're going to hook it up to the execution layer client, which is hooked up to the consensus layer client. Next slide. Okay, so here's the links. Maybe somebody can copy paste them and put them in the chat of all the different things that we need to get going with Polygon. So we need those 3 different binaries. We've got the latest versions of everything there. Just to note about the instrumented, so consensus layer, I'm not going to talk about it. It's the same setup that you would already set up if you had a Polygon node. Follow the Polygon documentation. Nothing to add in value here, so I'm just going to kind of skip over that. For the instrumented Ethereum or GETH, Go Ethereum, whatever you want to call it. So if you look at the version number there, it says version Polygon 0.33-FH21. So the 033 is the upstream version that you would get from the Polygon Foundation. And the FH21 is the Firehose protocol version that this supports. So we're on Firehose protocol version 2.1, and we're using the 033 binary version. So the Streaming Fast team takes the releases as they come from released by Polygon. They add the Streaming Fast Firehose code into it, and then they do a release. So you always need to use the releases that are coming from the Streaming Fast team, not the ones that come, the original ones from Polygon. So very important, don't try to run the original one, it's not going to work. And then you need the Firehose binary. This is the latest version is 133. There's all regular releases by the Streaming Fast team, and Anna gives us updates every week when there's a new version. So we need that one as well. We also need Prometheus and Grafana. I'm not going to describe how to install Prometheus or Grafana. Feel free to Google how to do that, but I will give you the relevant information on what you need to do to set it up. Next. Okay, so here's the config. Very, very complicated. Not. Okay, so this is just one YAML file, which has all the configuration you need to run Firehose. If you create this YAML file, put this in it, and start Firehose, everything works. That's it. End of discussion. Great, we can finish early. No, kidding. Okay, so let's look at it in one piece at a time here. So you can see at the start, what has the word start? And the start means that's the piece of Firehose we're going to run. So Firehose has a bunch of subcommands. So the start subcommand is the one that actually executes everything. So we're going to configure start. And we're going to run a bunch of different modules. We're going to run the merger, the Firehose, the reader node, the relayer, and the index builder. And if you remember the diagram from a couple of minutes ago, that was all the pieces on the diagram. So yeah, so we're going to run all of those components in one Firehose binary. And then we're going to provide some flags. So where do we want all the data? Feel free to customize this as you want. Put the data where you want. We need the chain ID. So Polygon is chain ID 137. So we need that here. We need the execution layer client. So wherever you happen to put that there, user bin GETH. And then we need all the arguments that we're going to pass to that in order to get it to work. So, all the rest of the config file is just command line arguments that we're going to pass to Go Ethereum. So that's all one big long line there. I just wrapped it so it fits on the slide. So any questions so far? Nothing too much. All right, let's move on. And I should say, can you just go back a second? So if you want to run a different blockchain other than Polygon, hopefully it's clear from what I explained here, but you need to change the chain ID to whatever the ID is of the other chain, like Ethereum or BSC or BNB they call it now. And then you need to change the arguments that you're going to pass. And other than that, the configuration is basically the same. Okay, let's go. Okay, so now we're going to start. So user bin fire ETH. So fire ETH is the Ethereum version of Firehose. And then pass -c for the config file. Wherever you put the config file, feel free to put it wherever you like. And then start. So we're going to tell it to start. Once it starts, away it goes, and it should start trying to connect to peers. And it will create a data structure for you where all the files are going to go. So in the last presentation, I didn't mention the file hierarchy, but I did print it out here. So you'll notice there's kind of two subdirectories. There's one called reader, and there's one called storage. So the reader is a temporary storage, which would always be local on the file system where the reader component is running. Now here we're running all the components, so you're going to get all the directories, but that would just be specific to the reader. So as it's reading the blockchain, it's writing out one file for every block that it finds. So it writes it on the local disk. Once it's synchronized to the local disk, then it will push it into the storage system. In this case, we didn't configure any fancy storage system, so we're just using local file system to write the blocks. So everything that's the shared file system, in this case, we're not sharing it because it's really all local. But the storage subdirectory is where all the shared files are going. So you can see there's a directory there called one blocks at the bottom. So once the reader creates all the blocks, as it's finished it will write it to the work directory, and then it will move it over to the storage one blocks directory. When the merger runs, it's going to read the files from the one blocks directory, merge them into a file and put it in the merge block directory, and then delete the files from the one block directory. So you'll be able to see all the operations happening on disk. and everything's just local for you. Next slide. Yeah, we're not talking about substreams here today. We'll do another presentation on substreams. All right, so hardware requirements. Hardware. So look at really the advice, the best advice here is look at the hardware requirements that you're given by the blockchain in question that you want to run Firehose for. So I just looked at the Polygon wiki page, and they recommend 64 gigabits of RAM, 16 CPU cores, 5 terabytes SSD, and a gigabit per second network bandwidth. So that's kind of your base requirements. And then we're gonna, we need to add storage capacity for the Firehose blocks. We need a bit more CPU potentially for, processing all those blocks and serving it to the end users or graph node or wherever it's going. If you don't have many users, then you don't need that CPU, at least at this point. If you just configure a node according to the Polygon specifications here, you're good to go. So you don't need to really add anything other than the storage space for the blocks. Okay, next. Okay, so just looking at the storage space. So you need a full node. So that's a terabyte and a half or so. You need 3.5 terabytes for the Firehose merge blocks, and then the search index is 100 gigabytes. So I did put on the next line under, I did provide some details about what kind of storage. NVMe, PCIe, LZ4, whatever. Get fast storage to run your Polygon node. The merge blocks and the index, that can be on, much slower storage, just based on what you need. So we actually store things on HDD in a big HDD array. So on a big array of spinning disks, works fine for storing merge blocks. Okay, next. Okay, so now if you want to get started and you download and you have the latest Polygon snapshot, that will only generate the Firehose blocks from the time when you have your snapshot. It does not generate all the blocks from the Genesis. If you want all the blocks from Genesis, you need to start Polygon from Genesis. So this confuses a lot of people. They think, oh, I'll just get the latest Polygon snapshot, download it, put it there, and then magically I have all the blocks. No, it does not work that way. So Firehose needs to generate the block as the blockchain is synchronizing, kind of in real time. So if you want blocks from 2 months ago, well, the blockchain needs to run from 2 months ago. So this means that the startup time to get Polygon running is, well, significant, let's say weeks or months, because you need to synchronize the chain from Genesis. And this is the same for any of the Ethereum-based chains. The Firehose needs to read the blocks as it synchronizes the chain and generate the one block file, which then gets merged into the merge block file. Obviously, this is less than convenient for getting started. So on the next slide. Okay, but once you download it, probably you should not trust that I gave you the correct data. You should verify the integrity of the blocks that you have downloaded. So one of the things that Firehose has is it has tools. So we talked about Firehose Start before, or FireETH Start. This is FireETH Tools. And all of the Firehose commands actually have a help. So you can say FireETH Tools help, and then it says, oh, one of the commands is check. FireETH Tools check help. And it will give you more details. So get used to this, because there's like 100 different flags that you can pass to FireETH, and they do various different things. So get used to using the help command to figure out what you need to do. So anyway, so we can verify the integrity of all the blocks that we downloaded using FireETH Tools check merge blocks, which you give it the directory where the merge blocks are. You give it S to actually read the contents of each block file, open it up, look at all the blocks, make sure that they link one to the next. And then R0 : means start at block 0 and go to the end. So you can run this command on only a segment of the blocks, or you can run it on all the blocks. If you just want to check that all the blocks are there, but not check the integrity of the block itself, you can leave off the -s flag. But I definitely recommend check that you actually have a valid set of blocks, that they all link one to the next. Next. Okay, let's talk about Prometheus. So here's the all of the Firehose components publish data into Prometheus, and it publishes three interesting metrics for you. So head block number. So where is it at the block at the current time? Head block time drift. So take the current time minus the block time, and that's the drift time. So this is really easy to allow you to generate alerts if Firehose is out of sync, because you can just say, if the amount of time is more than X amount of seconds, then generate alert. And then there's a last one, which tells you whether the component is ready and it's serving data on its gRPC endpoint. So that's a yes, no kind of flag. The thing to note is that the merger lags behind the other components. So like the reader is reading the data from the blockchain, so it's going to be the most up to date. Then it's going to get relayed, then it's going to get merged. So each one of those components is keeping track of where it is in the time. And the merger needs 100 blocks. And then once it gets 100 blocks, then it kind of goes up to the next one. Then it waits till it has 100 blocks and goes up to the next one. So merger is always slightly delayed. So set a slightly less aggressive threshold on the merger compared to the others if you want to generate alerts. And I just, if you want to configure the different endpoint, just run fire eth start -help and look for the metrics related options, and then you can just add those to your config file. But by default, Prometheus is enabled, so you don't have to set it up. Next. And then this is just a quick Grafana visualization of that all-in-one node. So I just started a Prometheus, or I started a Firehose a couple of days ago just to make sure that all the instructions that I'm providing is actually working. And then I just grabbed a screen capture of it. So you can see each of the components is listed on the right side there. It's like block indexer, Firehose, merger, reader, relayer, etc. So you can see the status of each one. Next. Okay, so after you get everything running here and you download all the files, you have everything working, then what do you want to do next? Probably you want to create a container or a systemd unit file to run your Firehose binary. The systemd unit doesn't have to be anything very complicated. Just tell it to restart if it fails, is probably the main configuration. You do want to prune your Go Ethereum node on a regular basis. So a full node keeps all the state. You don't actually need all the state, so you can prune that off. So feel free to run the pruning. You probably want to do backups or a ZFS snapshot, especially for your Go Ethereum node. So if for some reason you end up with a merge block that goes missing or a one block that goes missing, and then we can't create a merge block, well, you might want to try rewinding the chain, or if you've got a backup, you can go backwards and then play again forward. So you want to consider backups, and then of course you don't want to lose all your merge blocks if the disk dies. So consider where you're going to back those up. Once you've got that basically working, then you can think about setting up a high availability solution for various components. And I just, as a reminder of how many you need of what. Yeah, and then don't forget to open your firewall part and your Go Ethereum node. Don't start sending piles of queries to it because the whole point of running that node is for the purposes of generating Firehose blocks. So better to not overload it trying to do something else with it. So just keep it for what it's meant to do.
Wonderful. Thank you so much. And there you have it, ladies and gentlemen, another very successful episode of Indexer Office Hours. Thank you all for coming along and listening. A special thank you to, of course, Matthew for sharing all of his insights on Firehose. Again, another very insightful conversation. And as always, we're going to post this up onto YouTube. So if you want to revisit, please do. And obviously, the slides are in the chat. So feel free to go check that out as well. Thanks, everyone. And we look forward to seeing you all again next week. Take care. Bye-bye.